So in this problem, this is on the bottom of page 12. It's an example. For the first time, you're going to see one that has a leading coefficient in front of the x squared. So what do we do to complete the square? First thing you do is you say, that's our a, right? Well, even when we're in, what's this form called? Even when we're in vertex form, what's out here? An a, right? In the previous example that we did, the a was 1 with no problem, right? But in this one, the a is -2. So what you want to do is you want to take -2, put it out front, because that's going to end up as the a in vertex form. So in other words, I'm going to make it so it does not disappear this time. That -2 will end up being this little a right there. Okay? So right at the beginning, we're going to take the -2 and put it out front. Now what we do is we hope that the b is divisible by that. And it is, right? 16, 2 goes into 16 nicely. I know it's negative. We'll deal with that later. But is 16 divisible by 2? Okay, then this problem won't be so bad. And the other example that some of you already did, or some of you might do tonight for homework, is the 21 divisible by 3. That's nice. It's good when that happens. When it doesn't, the problem can get really tricky, and you might want to find another way to get it to vertex form. All right? It's best when the b is divisible by the a. So here's what we do. We're going to separate the -2 and the x squared with a set of parentheses like that. Then we're going to divide the 16, positive 16, by -2. That's going to be the new coefficient in front of x. So what is 16 divided by -2? So that 16x becomes -8x. You see all this stuff going on here? The 4 gets scared of it and just wants to go on the outside and say, I don't even want to be there. All right? So the 4 just kind of pops out on the outside and says, I'm getting away from this. We'll deal with the 4 later when we try to figure out the leftovers. So we still want to add a mystery number called the square. And whatever we add, we have to subtract. But here's where these problems get tricky. First of all, we had to divide out the -2 in the front. Did that affect the 16? Yes. Did it affect the 4? No, the 4 just got separated from the whole group, and we'll deal with it later. But here's where else this problem will get tricky. Let's say we figure out what number we're going to add here. Let's pretend it's 3, okay? If you think, okay, I'm going to add a 3 and subtract a 3 because that's what we've been doing, that would be wrong this time. Because if you're adding a 3 to complete the square, what are you really putting there? -6, okay? Because it's part of this group that is being multiplied by whom? -2. So that's where the dilation will have an effect. So if we added a 3, let's get to the number we do add here. Let's quit with this 3 stuff because it's not right. What's half of 8 squared? So 16 is what we're going to add here, but it is not what we're going to subtract. We're not subtracting 16. That won't bring balance. You're going to add 32 to keep it balanced. Let's see why. Okay? Listen. We're adding a number inside of this parentheses, this grouping. So what we really had here is, what's -2 times x squared? -2x squared. What's -2 times -8x? 16x. So you have to consider this. What are we really putting in here? Not 16, but -2 times 16. Yeah, the net effect is we've added -32 to the problem. In other words, we've subtracted 32. So how do you counterbalance it? You add 32. This problem was tricky on two levels. Not only was it that you had to think about the 32 being here, but it was negative. So to counterbalance it, we added 32. So do you see why we did that, everybody? Everybody good on why it was a 32 and not a 16? Okay. Now it's time to clean everything up. Take a deep breath. And the -2 is the A. The parentheses are going to be the x minus h part. Let's figure out what the k is. Don't forget the squared, but let's figure out the k. That's usually the easy part. What do you have over here in the leftover region? Plus 36. That's our k. That's how far up the vertex will be. All right, this part isn't bad if you just think of three things. You know, really, math is a lot of stuff, but just breaking it up into little parts along the way. So now you're at the part where you're really just focusing on this. Okay? So the x will become x squared. Whatever this sign is goes here. Whatever half of the 8 was goes here. This is a parabola whose y-intercept is 4. Does it open up or down? It opens down. Has it been dilated? Yes. Do we still see the dilation? Where's its vertex? 436. We know a lot about it now. Does it have any x-intercepts? It's at 436 and opens downward. It's going to hit, and we'll find those at another time. Okay? What's its line of symmetry? X equals 4. And mirror point? 8, because you double the line of symmetry. 4, because that was the y-intercept. All right, converting between these two forms always will tell us 4 of the 5 things we need. The zeros we'll tackle at a later date.